Hello everyone, welcome to the data structure series. First of all, we are going to understand what is the syllabus and what we are going to cover in this series. In the data structure syllabus, we have total of 6 units. In first unit, we are going to cover about the introduction of the data structure, which includes the complexity analysis also. In second unit, we will see about array, and third unit, we will cover sorting and searching which is performed on the array. In fourth unit, we are going to cover linear data structures. For example, stack, queue, and linked list. In the data structures, mainly we will focus on the operations. Every data structure will try to apply some kind of operations. For example, insert, delete, sort, search. Mainly these four operations will be applied. And one more operation, which is obviously we have to print the element that is called traverse. That also we will discuss in the introduction, that is first unit. In the fifth unit, we have non-linear data structures, that is tree and graphs. And the last, we will cover the hashing. So let's start with the data structure, unit number one, introduction. First, we will see the definition of data structure. So data structure is a way of organizing or storing the data in such a way that the data can be used very efficiently, or we can say effectively. Okay, so in any program, whenever we use some kind of data structures, we want that any kind of operations we will perform that will be done very easily, and also that will have less time complexity and space complexity. Okay. This time complexity we are going to cover in the second lecture of the series. We can say that the data structure allow us to understand the organization of data and the management of the data flow in order to increase the efficiency of any process or program. Efficiency, we can say that efficiency means maybe it will take time, less time complexity or less space complexity. Or maybe some kind of operations will be performed easily on some kind of data structure. That's why we are learning about the data structure because it is used in every programming language, and without data structures we cannot implement or we cannot solve any problem. Now, let's come to the classification of data structure. In the classification of data structure, mainly we divide the data structures into two parts. One is primitive data structure, that sometimes we call the data types also, which includes int, character, float in the C or C++ language. The second is the non-primitive or user-defined data structures. These data structures will be derived from primitive data structures. That's why these kind of data structures are also called derived data structure. Or they are defined by user itself. That's why they are called user-defined data structures. In the non-primitive, mainly we will categorize the data into two categories, that is linear and non-linear. In the linear data structure, we have static data structure and dynamic data structure. Static data structures mainly are arrays. In the dynamic data structures can be stack, queue, and linked list. Stack and queue can also be static. It is depend on our implementation. How we are going to implement these data structures. Based on that, the data structure can be static also and dynamic also. But for now, I'm considering these data structures in dynamic. Then, nonlinear data structures. These data structures are trees and graphs. These data structures can also be dynamic. Mostly, we will implement this data structure as a dynamic data structures. Why? That we will see in some time. That we have some advantages of dynamic data structures. Okay. Primitive data structures. As I told you, the primitive data structures are the data structures which are inbuilt into the programming languages. For example, integer, float, character, boolean. When we define such kind of data types, A, B, C, like this, so these kind of data structures are called primitive data structures. Okay, non-primitive data structures. The non-primitive data structures are those data structures which are derived from primitive data structure. The focus of these data structures is on forming a set of data elements that is either homogeneous or heterogeneous. Meaning is whenever we try to define some data structures like array, let's suppose I'm trying to define this data structures here. Okay. Now this data structure is array, and by default, you know that this kind of data structures we can define on the same data type only. Means if similar kind of data types like only integers, all the data or all the elements inside these data structures will be of same type, that is of integer. Sometimes we can define the data structures on different data types also. Okay, the example of these maybe you have seen in the class in the C++. Okay, or maybe in C language also you have seen the structure, union. All these user-defined data types are called heterogeneous data types also. So based on the structure and arrangement of data, we can divide these data structures into two subcategories. One is linear and non-linear. Linear data structures sometimes they can be arranged in form of sequential data structures. Okay, the data structures in which data elements are arranged sequentially or linearly, where each element is attached to its previous and next adjacent element. And this type of data structures are called linear data structures. Let's suppose this is the array that we have defined right now, which is of 5 elements. So here you can see that these data structures are defined in contiguous fashion, okay, or sequential fashion, 2 after 3, 3 after 4, 4 after 5. Yes, even in linked list, you see the linked list, and linked list also is said to be linear because we can traverse all the elements of the linked list one by one, or linearly we can say, linearly we can traverse. So let's suppose this is the example of a linked list, okay, that we will discuss in detail, that how we can perform the operations, how we can traverse the linked list. Okay, so this is also data structure which is linear. Non-linear data structure. Data structures where data elements are not placed sequentially. Okay, they are not in linear fashion. Let's take one example of a tree. This is a tree example. In this example, you can see that the data structures or data elements cannot be performed, or data structures which don't have sequential access. These data structures we cannot traverse in single run. Okay, so these kind of data structures are called non-linear data structures. One example of graph is like this. Next, next we are going to see the definition of static and dynamic data structures. Static data structure has a fixed memory size. It is easier to access the element in a static data structure. Now, whenever you heard about the static and dynamic data structures in programming language, you can say that whenever we define some data structures at static time, or we can say at compile time, then data structures will be fixed. The memory we allocate will be fixed. We cannot change at runtime. Okay, let's suppose the example of array. In array, whatever we define, for example, if we have array of size 5. Now, if we want to change the array size, then we can change it before running. After running the program, we cannot change it. Next is dynamic data structure. So, whenever we define data structure as a dynamic, then we can change the size of data structure at runtime. Means after running the program also, we can change the size. Okay. So there will be some advantages of dynamic data structures. Dynamic data structures will be taking less, or we can say memory wastage will be less in the dynamic data structure because we can delete the memory at runtime also. Whenever we try to insert the value, we will allocate some memory, and if we try to delete the memory or delete the element, then we will free the memory. In this way, the memory utilization will be efficient in this case. So example of this is data structures can be queue, stack, and linked list. Although the queue and stack we are going to perform with the help of array only, that is static data structure. But we can perform or we can implement queue and stack using dynamic data structure only. As I told you in the syllabus, mostly we are going to see operations on the data structure. So what kind of operations? Mostly there will be insert, delete. These are the two main operations. With the help of that, we can create data structures. Then in the end, always we will see what are the elements of our data structure. So we can traverse all the elements, or sometimes we can use the term display or print the elements. Other than that, we can sort and search the data, yes, and we can manipulate, update, or modify also. Okay, sometimes we can use other operations also, maybe merge. Okay, but all other than this, all other operations will be including any kind of insertion or deletion, or maybe searching. So these are the operations which we will perform on every data structures. So this is all about introduction of data structures and the classification of data structures. In the next lecture, we'll see the complexity analysis. Thank you.